Good evening, guys. Good evening. Welcome to Unacademy, India's largest learning platform, which is helping the students of all walks of life. You may take engineering, medical, junior inter, other exams, UPSC, NET, NEET. You name whatever. Unacademy is with you. Unacademy is with you. 100% supporting, full free of cost. Full free of cost. Everything is given free of cost. You dream it, we will realize it. We are here to help you. Unacademy is here to help you a lot, to make you successful. Good evening, Vasu. Good evening, Krishnaveni. Very good evening. So, welcome to Unacademy once again. So, we are discussing a subject called electronic devices. Electronic devices. So, which is helpful for the students who are preparing for GATE and ESE. And this is also useful for the regular engineering class also. So what are topics I am covering, which will also help the students who are studying their engineering right now. Okay, so today is the lecture number 24. So we have BJT configurations. We have BJT configurations. Yeah, we'll move on. Yeah, myself, Shravan Kumar, having master's degree from JNTU Hyderabad, and I have 10 plus years of teaching experience. And then I can teach the subjects EDC, analog electronics, digital electronics, and EMFT. So EDC, this is hopefully the last class on YouTube, and we'll be migrating it to the app. At the end of the class, we will discuss, especially with Vasu and Krishnaveni, we will discuss the timings, how many hours we will I have to teach. We will discuss about this because from Monday I'm going to start a crash course on analog electronics from 4 p.m. to 5 p.m. 4 p.m. to 5 p.m. So hopefully our class will be after this 4 p.m. to 5 p.m. and we'll discuss about the timings according to your timings also. So that it will be beneficial for both you and me, right? So that I'll be happy if you come online and listen to my classes. Okay, yeah. Now we have a promo code called SVS10. Which will be helping for you to get 10% discount on Unacademy Plus subscription. Unacademy Plus subscription. Okay. So what are the advantages of having Unacademy Plus subscription is you can attend all the live classes. You have a crash courses. Facility, and you have a weekly test. This is most important for any engineering student who is writing the GATE examination. This weekly test is very important. And you'll have something called double doubt solving sessions. Every 4th hour is going to be a doubt solving session. And you'll have sessions in English and Hindi. So the medium of communication may be in Hindi and English. The local language we are not, though I am from Telugu, right? Telugu వాడినైనా సరే అందరూ ఇంగ్లీష్ నేర్చుకుంటే మంచిదని నమ్మేవాడిని నేను. ఆఫ్ కోర్స్ నేను కూడా తెలుగు మీడియం నుంచి వచ్చాను. But I struggle hard when I was studying my engineering. I made up my mind that I should become a good English speaker. I think I'm speaking a sensible English, not a bad English, right? That you should tell me, Vasu and Krishnaveni. I struggled through my life a lot. Anyway, that is not the topic right now. We will discuss someday. So the success story of my whole story. Will have a interactive session. Then we will see some beautiful moments of my life also. Okay. Yeah, I have something called a rank improvement batch. So the advantage of this rank improvement batch is those who are having no issue, Vasu. We will have classes in the evening. Vasu will have classes in the evening anyway. This time, either say 6 to 7 or 8 to 9, like kind of thing. You need not worry. You need not worry. We will have a comfort. Evening anyway. Evening you will be free, right? Evening you will be free, right? Class will be mostly in the evening only. I think your college will end by 4 o'clock, right? Your college will end by 4 o'clock, right? We will discuss Vasu at the end of the class. At the end of the class, we will discuss about the timings, right? Okay. This is the advantage of having plus subscription, and we have another subscription called iconic subscription. The benefit of iconic subscription is you will have a personal coach, you'll have a study planner, you have a study booster sessions, and you'll have a personalized test analysis, which is very important, and you have something called preparatory study material, which is very much important for those who are preparing for gate examination. Okay. And what are the fee structure for a plus subscription going to be? A plus subscription will have a 12 months course. So where the fee structure is going to be 27,225 rupees, and you have a code SVS10, so that you'll get 10% discount on that. And for 18 months, you have 34,650 rupees. SVS10 is again the code, and then for 24 months, you'll have 39,600 rupees. So this for this also you have 10% off, 10% off on the free if you use this referral code called SVS10. SVS10. This is a plus subscription for this iconic subscription. Iconic subscription will have a 12 months course and 24 months course, which is having this fee structure. So where you will get 10% discount on both of them. 10% discount on both of them if you use this SVS10. So what are the advantage? How can you pay? You can use wallets, many wallets which you know right now. You have wallets, you have EMI facility, and then you have something called credit card facility. So whatever you want, we have these facilities. Okay. Yeah. So those who did not download yet the Unacademy learning app, I would request you to go and download this Unacademy app. So and install so that you'll have a lot of benefits. So the third step is you have to select your goal, that is GATE and ESE. GATE and ESE to manage your goals. GATE and ESE is very important. Right? Select your goal. And step 4 is going to be you need to select something called plus. Once you select a plus and hit subscription, you will be allowed to pay the amount and you can do that. And apart from that, you will have 2 other courses, that is free courses and special courses. These are for free of cost. You can attend. Anybody can attend any. The top Indian faculty are there for GATE and ESE. Okay. Now this is what I'm talking about. This is a free special class series. Please, free special class series, which is named as a Know Your Basics. So which is targeting for 2022 and 2023 engineering students. I mean GATE students. So what the benefits is you'll get a complete roadmap to approach each subject of every branch. You can understand the subject by strategy to crack GATE 2022 and 2023, right? And you will have introduction and guidance by India's top educators across all the branches. So okay, across all the branches you will have. So you will have a mechanical engineering, civil engineering, electrical engineering, ECE, CSEIT, and chemical engineering, right? So this all starts. This already started from December 20th. Right? This is started from 20th of the December. Okay. So you can follow me on Unacademy. You can use this code, something called Unacademy user ID. This is what user ID. You can follow me, right? Okay. So yesterday we were talking about the current components in transistor. Before that, just we'll try to summarize what we have discussed in the previous class. For quick thing, I think we have discussed yesterday the solar cell. We have discussed in detail about solar cell. Solar cell, sorry. This is what the diagram of solar cell, where n is very small and p is very high, big, when compared with others. So this is what something called finger electrode, where you'll have electrodes which will absorb the solar energy, and which will try to generate the voltage. So they are called solar cells, and this is called the bus, which is used to get the data. And these are the IV characteristics of a solar cell. That the dark is nothing but whenever there is no light falling on it, it acts like a normal PN junction diode. But when it is when light is falling on it, depending on the light falling on it, you will get different currents. You will get different currents depending on the light falling on it. As the light falling on it increases, but illumination, the dice, nothing but illumination. As the illumination increases, the current generated by this increases. You can see here. You can see here you have two electrodes. You have two electrodes. So this all we discussed. And we started our discussion with bipolar junction transistor. So as I told you, there are two types of transistors, unipolar and bipolar transistors. So this was invented by three scientists in 1947, Bardeen, Breton and Shockley, which was invented at the Bell Laboratories in America. And transistor can be used as a amplifier and electronic switch, electrically controlled switch. This is what we discussed. And then we have discussed what is unipolar and bipolar. So whenever there is a conductivity is because of only majority charge carriers, then it is called unipolar. And bipolar means you have the charge carriers which are holes and electrons, which are both holes and electrons are having charge carriers, and current is because of both holes and electrons. Because of that, it's called the bipolar transistor. Because of that, it's called bipolar transistor. And we have seen the classification of transistor. You have BJT, FET. BJT is again two types, NPN, PNP. FET is again JFET and MOSFET. As I told you, this we will discuss after the completion of this complete concept of BJT. Complete concept of BJT. And we have two types of transistors depending on the structure. They are called NP and PNP transistor. So we have seen what is the sandwich. So one type of semiconductor material is sandwiched between two other types of the semiconductor. Then it has become NPN and PNP depending on what type of semiconductor is sandwiched. What type of semiconductor is sandwiched? So based on that, we have differentiated two transistors, that is NPN transistor and PNP transistor. NPN transistor and PNP transistor. And we have seen the symbols. Everything we have seen. This is a symbol of a transistor. These are the three electrodes. As diode has two electrodes, anode and cathode, we have three electrodes here. So each electrode is called emitter, base, collector. Emitter, base, collector. We have discussed in detail which one is called emitter, which one is called why this is called emitter, why this is called base, why this is called collector. And we have seen there are two junctions. There are two junctions. First junction is in between emitter and base. So because of that, we call it as emitter base junction. And this junction is in between base and collector. Because of that, we call it as a collector base junction. Collector base junction. Collector base junction. And we have seen the symbol. In the symbol also, we have differentiated between, anyway, base can be easily identified. But to differentiate between emitter and collector, we use the arrow mark. And there is other possibility that an arrow mark can be from B to E or E to B. So depending on the arrow mark in the given. Good evening, Balaji. The arrow mark in the symbol represents conventional flow of current. Conventional flow of current. So always current flows from P to N. P to N. So whenever this is the arrow mark is going out of the base, then it is an NPN transistor. NPN transistor. If the current direction is inside, this is how I have discussed. If the current direction is inside, this current direction is from emitter to P, then it's going to be PNP transistor. PNP transistor. Pritam, good evening, Pritam. PNP transistor. PNP transistor. Okay, this is how we differentiated, and we have seen that we have three terminals: emitter, base, collector. I'm just trying to repeat them. So emitter, what is the job of emitter? So emitter has to emit. Emitter has to emit the charge carriers. Emitter has to emit the charge carriers, because of that it is heavily doped. It is heavily doped. It is heavily doped. And the base has to be very thin inside and lightly doped. Thin inside, lightly doped. And collector job has to collect the charge carriers, and hence the area of cross section of the collector is more compared with the emitter, and it is moderately doped. Okay, so this is moderately doped. So collector, and we have seen this is what we have seen, a comparison table. So the size of the emitter base collector is nothing but here, as I told you, collector has a large in size, base is very thin, smallest is base, and emitter size is medium. Okay, and doping concentration will be high for emitter, and moderate for collector, and lightly for base. This is what we discussed. And we have two PN junctions. They are emitter base junction, collector base junction, collector base junction. And we have three regions of operations. That is active region, saturation region, cutoff region. Active region, saturation, cutoff region. So we have seen why we got these four combinations. So one is called for one junction we have two biasings, one forward bias and reverse bias. But two junctions we have four combinations. That is junction 1 and junction 2. So you can have forward bias, reverse bias, and forward bias. And we have this emitter base junction, collector base junction region. And when both junctions are forward bias, it is called saturation. When one emitter base junction is forward bias and this reverse bias, collector base reverse bias, is called active region. So when both junctions are reverse bias, it's called cutoff region. And the fourth is, I asked you to know what is this reverse bias and forward bias. Do you have answer, sir? Does anyone inquire? Does anyone refer any textbook? Okay, Balaji. Okay. Carry on. No problem. Carry on. So we have discussed about what is active region, what is saturation, what is cutoff region, and we have seen how transistor can be used as an amplifier and switch. So what do you mean by amplifier? Means it has to be operated in active region. Means emitter base junction should be forward bias and collector base junction should be reverse bias. And a switch is nothing but it can be either in saturation or cutoff region. So for the transistor to act as an amplifier, it should be operated. This is what we discussed. And transistor operation we have seen how NPN transistor will operate, how it functions, right? So we have seen this. How the emitter base junction is forward bias and the collector base junction reverse bias, and what happens is the majority charge carriers in the N region or electrons, they will be repelled by the charge. They will be repelled by the negative terminal of the battery. So that now what happens, sir? All the charge carriers will try to jump from emitter to collector. So in between, 5% of the charge carriers will be recombined. So because of that, we'll get some current called IB current, and remaining 95% of the current will flow to this. So because of that, now we have seen what is that, sir? I is equal to IB plus IC. IE is equal to IB plus IC. IE is equal to IB plus IC, which is correct for anything. So this is what we have discussed. This is what we have discussed. IE must be always, emitter current is always must be equal to the base current and collector current. Emitter current must be always equal to base current and collector current. Emitter current is always equal to base current and collector current. And we have PNP transistor. For this also, what we have discussed here, this junction is forward bias and this junction is reverse bias. It means the holes will try to move from emitter to collector, and meanwhile 5% of the charge carriers will recombine here. I mean, remaining 95% will enter into the collector region. Now current flows, and we have seen. So IE is equal to IB plus IC once again. So I is equal to IB plus IC. This is what we discussed. This is what we have discussed. Okay. Now, so now we are supposed to discuss about this current components. Now we'll go to the today's class. Yeah. So here comes today's class, something called current components in a transistor. Current components in a transistor. This is a very important concept. This is a very important concept. All you need to remember this. All you need to remember this very carefully. Because if you understand this concept, the current components, you'll understand the complete functioning of a transistor. So how many of you are there, sir? Are you there? How many of you there? Just say hi. Just say hi. Krishnaveni is there. Good, Krishnaveni. Vasu is there. Good, Vasu. Okay, remaining all are in mute. It seems. That's okay. I'm happy about both of you. Thank you for joining me. Now we'll see what is a current component say transistor. Sir, I try to explain this with our clear discussion, because you need to definitely understand this concept. Very important concept. Though it is there, but from the scratch I'll explain you so that you will not have any issue. I'm just trying to explain you in detail what we are doing here. Just bear with me for a few minutes so that I can start explaining the current components concept. So this is what I think we are discussing about either PNP. Yeah, this is PNP transistor. So this is going to be a P, this is going to be N, and this is going to be P. This is PNP transistor. PNP transistor. Very important, sir. Very important. Just bear with me. Now you can see here, this is the positive terminal, this is negative terminal, this is negative and this is positive. So if it is P is connected to positive, and this is emitter, this is base, and this is collector. And the junction is called emitter base junction. This is called emitter base junction, and this is called the collector base junction. Right? So very importantly, Now you can see here. First thing, just think about only this emitter base. We'll come back to collector later. We'll come back to collector later. First, just think about this Pn. This Pn. We know that this P material, that is P semiconductor material, definitely will have holes here. Many holes will be there, right? Many holes will be there. Many holes will be there. Many holes will be there. And the majority charge carriers are holes. Majority are holes, and minority charge carriers are electrons. Minority charge carriers are electrons. It means it will have minority charge electrons will also be there. Now, whenever this positive terminal of the battery, is connected to the P type of semiconductor metal, and the N type is connected to the negative terminal of the battery, obviously the holes which are present, the majority charge carriers which are present in the P region, the holes which are present in this P region will definitely move away, and they move toward the junction. They'll cross the junction. So whenever the charge carriers are moving from here to here, definitely there exists a current, and that current we call it as, definitely this current has to flow, and we will name this current as current IP, the whole current in P region. That is whole current, whole current, whole current, whole current IPP, whole current IPP. Okay, whole current IPP, whole current IPP, whole current IPP. Okay, now you should also think about the minority charge carriers which are present in the P region. So what are the minority charge carriers? What are the minority charge carriers in P region, sir? The minority charge carriers in P regions are electrons. The electrons, now what will they do, sir? The electrons will be attracted by the positive of the battery. Positive of the battery. All holes are moving in this direction. Holes are moving in this direction. But what electrons will do? Electrons will move away from the junction, and they'll be attracted by the positive of the battery. So electrons will be moving in this direction. Electrons will be moving in this direction. Electrons will be moving in this direction. It means, now what is the current because of these minority charge carriers? What is the current because of these minority charge carriers? The current because of these minority charge carriers is nothing but, I can say, INP. That is electron current. Electron current. That is electron current. So when electrons are moving in this direction, what would be their current? What would be their current? Their current direction. What is current direction? Exactly opposite to their move. Exactly opposite to their movement. Exactly opposite that movement. Means we have this current. We have this current INP. INP, that is electron current in P region, electron current in P region. Now you see why I have drawn like this also. You can see here, obviously the IP will be very high. That is the reason why I have drawn here. I can draw this IPP here also. No, because to make a difference, and know that this whole current is very much higher. This whole current is very much higher. So because of that, I have drawn like this. So the current in the emitter, is nothing but, I can say, this IE is equal to, simply emitter current is nothing but IPP plus INP, sir. Both currents will exist. We named it as bipolar or not? We named it as bipolar or not? So simply we didn't name it bipolar. Simply we don't name it bipolar. It is, the current is because of both electrons and holes. Electrons and holes. In the earlier cases, the current may be either because of holes or electrons. But in this case, at a time, the current is because of both holes and electrons. So because of it, it's called bipolar, 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 bipolar. Now, as I told you, after this, now the current has to flow. The current has to flow. So the current has to flow. Now what happens, sir? The current which is flowing will has to move from here to here, here to here. Now what happened here? Now what happened here is few parts of the current, few parts of the current, few parts of the current is falling, and few part of the current is falling. So you can see here this current is falling. This current is falling, and now this current is now you see now you see the beauty here. Now you see the beauty here. Whenever these holes are crossing, and again they are entering into this. So now what happens here? They'll again becomes the majority charge carriers here. The majority charge carriers here. So as this emitter base junction is a forward bias, as the emitter base junction is forward bias. Now what happens here? Now you see another beauty here. Now you see another beauty here. The charge, what are the charge carriers? Of course, this B is lightly doped. The base is lightly doped, but still there exists a current or not? Still there exists a current or not? Now what happens, sir? This negative terminal in the battery will repel the charge carriers which are present in the B base. Obviously, there exists a current because of them also. The same current is now you can represent like this. Obviously, the current direction is also same. Is there any change in direction? No need to change direction. No need to change direction. So the same current is flowing here. I can call this current actually after entering. I can call this as INN. No problem actually. INN current, and this is going to be IPN. This is going to be IPN. Again, in this case also, the current is same, which is summation of whole current. This both currents are because of whole current. This is because of electron current. So the again summation is going to be INN plus IPN. INN plus IPN. INN plus IPN. INN plus IPN. So these currents have become okay. Now you can see here again this current is entering now. Can I call this current? This IE I told. Now can I call this current IC? IC collector current. Collector? No. I'm not talking about collector base. Collector base. I'll come back to collector base also later. I'm still talking about this. I'm still talking about this emitter base junction. Emitter base junction. The charge carriers which is coming very fastly, will definitely, though this is reverse biased, these charge carriers will definitely enter into a collector. Now, coming to this your point, this collector base junction is reverse bias. Sir, when the collector base junction is reverse bias, so what do you mean by this? When this junction is reverse bias, there exists a small current. Called reverse saturation current, and it is because of the collector. I'm calling this as IC naught. So generally I represent it with I naught. But this is because of the collector. This is in the collector. The reverse saturation current is in the collector region. So because of that, I called it as a IC naught. It means the electrons are moving. In the opposite direction. So now what happens, sir? You will find this. current direction as IC naught. IC naught. See the beauty. See the beauty. So now it has again I is going to be IPP plus INP. Here also INN plus IPP. INP plus here also what happens, sir? IPP. Then this current is going to be again. You'll have another current called IC naught. You have another current called IC naught. So what this current can I call this current? Can I call this current as IC? Sorry, IE minus IC. IE, that is IE minus IC. That is emitter current IE. Emitter current IE minus IC. Emitter current IE minus IC. Okay, the total current is represented with IE minus IC. So these are the different current components present in the given bipolar junction transistor. Bipolar junction transistor. So let me see if did I miss anything. I'll go back and see. So here the emitter consists of the following two parts. One is the whole current. So it is represented with IPE, that is emitter current. This is correct actually, right? IPE we call it as I represented with IPP, but here I can call it as IPE, which is considered a whole current, that is IPE, and you will have INE, that is because of the minority charge carriers, or the electrons crossing from the base into the emitter. So always remember the total current IE is going to be the combination of majority charge carrier current and minority charge carrier current. Majority charge carrier current and minority charge carrier. What are the majority charge carriers here, sir? In emitter, it's going to be holes. So this whole current plus electron current. Whole current plus electron current. Whole current plus electron current is going to be I is going to be IPE plus ING. IPE plus ING. So the whole crossing the emitter base junction JE and reaching the collector base junction JC constitute a current IPC. IPC. It means he is talking about this. Sorry, he is talking about this current. So he is representing this with IPC. IPC. I call this as a IPE. He is naming it as IPE. This is going to be INE. So whatever INE and IPE. IPE and ING, I am talking about IPC, IPC, IPC. So not all the hole crossing the emitter junction reach the collector base junction JC, because some of them combine with electrons. This we have discussed. So the spins, the base width is very small. Most of the holes cross the collector base junction, and very few recombine. And this is what I am talking about. This is what I am talking about. The current, the total current is going to be IPE minus IPC. And this is base current. Base current is going to be IPE minus IPC. IPE minus IPC. Okay. So now, when the emitter is open circuited, when the emitter is open circuited, I is equal to 0, and hence IPC is going to be 0. Under this condition, the base and collector together current IC equals to the reverse saturation current IC naught, which constitute the following two parts. Okay, what is that point, sir? IPC naught, caused by the holes moving across IC from N region to P region, and INC naught caused by the electrons moving across IC. So IC naught, that reverse, this IC naught is going to be a reverse saturation current, reverse saturation current in collector is going to be IC naught, which is a combination of INC naught plus IPC naught. In general, the collector current is going to be INC plus IPC. Thus, for a PNP transistor, remember this is work. That is IE, emitter current is always equal to base current and collector current. Remember this, very, very important. Emitter current is always equal to base current and collector current. Base current and collector current. This is very important. Base current and collector current. Now we will start today's topic, something called transistor circuit configurations. Transistor current circuit configurations. Following three types of circuit configurations. See, why this? Why this? Uh, uh, Common base, common emitter, common collector. So why this word some common is come? Why do we need to take some word common? Why do we need to take some common? Sir, I'll explain you with a small funny thing. So hope all of us played cricket in our young ages, right? I'm talking about when you are in schools. When you are in schools, you might have already played cricket very much. Let's say you have a you have 11 let's say 9 members are there in your friends. All 9 members wants to play. All 9 members wants to play. If 9 members wants to play, if 9 members wants to play, so one team consists of 4 people, other team consists of another 4 people. You'll have another fellow who will generally we call him as a joker. Generally, we call him as a joker because he has to play for both the teams. He has to play for the both the teams. But generally, that guy will not get batting. Always he has to do some fielding. The joker generally what will do, sir? The someone who is common for both the teams. We ask him to either bowl or field. We don't give him bat because we say you can play in the last. You can play in the last. Yes or no? Yes or no? So this is a funny thing which we'll do. I think every one of us might have done the same thing when we are playing cricket, when we are in a young stage, when we are in youngsters. Yes or no? Right? If let's say if you have 5 players, what will you do? So let's say you have 7 players. So 3 will be one team, another 3 will be another team. So one fellow will be acting like a joker. Another fellow will be acting like a joker. So now what this joker is common for both. Joker is common for both. Joker is common for both the teams. Joker is common for both the teams. So because of that, now what we are doing here also the same. What we are doing here also the same. What we are doing, sir, as we have only 3 terminals, as we have here only 3 terminals, we have 3 terminals. We have 3 terminals. We are just 3 terminals. So because of which now what we are doing, sir, one terminal is on side, one terminal is on the off side. So one terminal is on our input side. One terminal is on input side. So one terminal is on the output side. So the third terminal will be always shared by both input and output. Shared by input and output. Right? So one terminal is on input side, the other terminal is on output side. So one terminal will be shared by both input and output. If you look at like this, obviously at one configuration, one terminal has to be base. Sorry, one terminal has to be common. One terminal has to be common. Generally, what happens, sir? While you are playing cricket, also we can say, "Hey, yesterday I was the joker. Today you have to become a joker." So we'll try to rotate the joker also. We'll try to rotate the joker also. Yes or no? We'll try to rotate the joker also. So similarly, here also same thing. So for one combination, base is common. For one combination, emitter is common. So for one another combination, collector is common. Collector is common. So this is a simple funda. This is the simple funda which we will do. Right? So same thing. So if the base is common for both input and output, the base is common for input and output, we call it as a common base. Common base. If the emitter is common for both input and output, the emitter is common for both input and output, we call it as a common emitter. If the collector is common for both input and output, then it is called common collector. Common collector. So based on our discussion, now what we will get is these three combinations, which are the most important combinations. So this CE is important combination for all of us. So most of our discussion will be on common emitter. I'll let you know the advantages of common emitter. There are many advantages for common emitter configuration. There are many advantages for common emitter configuration. Now, we will discuss about each one of them in line. We'll discuss about each one of them in line. Yeah, the term common is used to denote the transistor lead which is common to the input and output circuits. The common terminal is generally grounded and generally the grounded, right? So this is very important. In general, he is saying in general. I'll tell you why generally also. He did not say always. He did not say always. Always grounded. No, he did not say. I'll tell you why also. There is some problem if somebody says always. He said generally. He said generally. Generally. Okay. It should be remembered that regardless of the circuit configuration, the emitter is always forward biased, while the collector is always reverse biased. So this point you should understand. This point you should remember. Irrespective of whether which one is common, either emitter may be common, collector may be common, or base may be common. Irrespective of that, forward this emitter base junction should be forward bias and collector base junction should be reverse bias. We should not cross this. Emitter base junction should be definitely forward biased. Forward biased. Forward biased. So forward biased. Irrespective of the common. Irrespective of the common terminal. So what is collector base junction then? Collector base junction should be reverse bias. Collector base junction should be reverse biased. Remember this point. So emitter base junction has to be forward biased and collector base junction should be reverse biased. Emitter base junction has to be forward biased and collector base junction should be reverse biased. Always remember. Always remember. So irrespective of the common terminal, either a common base, common collector, common emitter, right? This point needs to be remembered. This point needs to be remembered. Okay. Okay. Now we'll move on. So now you see here, what is a common base configuration? Common base configuration. You see the beauty of this circuit. Which type of transistor is this, sir? Which type of transistor, sir? Always when current is from upward direction, obviously it has to flow from PNP. This is PNN. That is NPN transistor. NPN transistor. Here what happens, sir? This current is flowing towards into the base, so it has to be PN. The other should be P. PN. Other should be C. P. So as I told you, this junction base is common. The base is common. Now one terminal has to be at input side. The other terminal has to be at the collector side. Correct, Krishnaveni and Vasu. You are right. You guys are right. Very good that you are listening. So now you can see here these two junctions. This base is common for both things. But here comes a doubt, sir. Why input is emitter is at input side? Why collector is output side? Why emitter is at the input side? Why collector is at the output side? So what is the job of an emitter? What is the job of an emitter? Remember, always the job of emitter has to emit. It has to emit the charge carrier. It has to emit the charge carriers. So because who is supposed to collect? Collector has to collect. Collector has to collect. So always the job of emitter is to emit. and collector of the collector has to be at collector. So you may ask, sir, why don't we make this collector as input and emitter as an output? The problem is in the basic structure and the design of a transistor, which we discussed in the previous class. Correct, Krishnavani, correct. So basic our discussion, according to our basic discussion, this has to emit. It means it is a source. It is a source. Generally, emitter is nothing but a source kind of thing. So always remember, source must be at the input side. Always remember, at source must be. It means for only one configuration, emitter will not be there at the input. For only one combination, emitter will not be there at the input. What is that combination, sir? Common emitter, common emitter, common emitter. Clear? It means, so most preferable input side is always emitter. Most preferable input side is always emitter. Most preferable output is collector. Most preferable output is always collector. Is the point clear? Most preferable output is going to be collector. Most preferable input should be always emitter. Many students will forget, will confuse while they are drawing it in the examination. While they are drawing it in the examination. Remember, the job of emitter is to emit, so it should be always preferable that emitter should be at the input side. There are three combinations: common emitter, common collector, and common base. Right? So only for common emitter configuration, emitter is not the input. Emitter has to be grounded. Emitter has to be grounded. So the input side for the remaining two combinations, that is for common base and common collector, emitter has to be at the input side. Remember my point. Remember my point. This is very important. Don't get confused. Don't get confused. Right? So collector job is to collect. So always it is preferable to collector to be at the output side. At the output side. Or at the output side. Okay. So this is for NPN. So this is NPN. And this is going to be PNP configuration. This is going to be PNP configuration. Okay. Now we'll see what is common emitter configuration. So for common emitter configuration, now you may get a doubt again. Just now we discussed. As I told you, when the emitter is grounded, first let us see which type of transistor is this. So as current direction is like this, it means it is P, it is N. Obviously this is N. Again, this is going to be NPN. So if the current is going from here to here, it will be PNP. So it's going to be PNP transistor. PNP transistor. Now, as I told you, when the emitter is grounded, what are the two remaining choices? So what are the two remaining choices, sir? So at the input side, you have a chance of base and collector. At the output side also, you have two chances. That is collector and base. As I told you just now, always collector is preferable to be at the output. Always the collector should be preferable at the output. So now what we decided, sir, we have taken decision that output should be collector. And the output should be collector, emitter is grounded. What's the remaining one, sir? Base. There is no chance that base has to be at the input. There is no other option. So remember this, sir, because I see the toppers of the class also I have seen doing mistakes in this. They get confused. When they are listening. They are very good listeners. But the problem is when they are writing the exam, they'll definitely get confused. Only thumb rule you should remember is emitter should be always at the input side. Collector should be always at the output side, preferably. In the brackets, it is preferably. So preferably, emitter has to be at the input side and collector has to be at the output side. So when you have a chance of putting collector at the output side and the input side, definitely 100% you will prefer to be it at the output side. So what is the remaining one? The base is the remaining one. So base has to be at the input side. Now here comes another configuration, that is PNP configuration. In the PNP configuration also, what will do, sir? Obviously, when the emitter is grounded, collector has to be at the output side. The base has to be at the input side. Base has to be at the input side. This is going to be grounded. This is going to be grounded. This is going to be grounded. Next. Common collector. Common collector. Common collector. Now, this is very important. This is very important. This common collector is important. Now, when I am seeing this common collector, this collector is grounded. This collector is grounded. Now, just now I told you that this emitter is to be at the input side. At the input side. Now, the problem comes if the base is at the output side. If the base is at the output, now first we try to understand what type of transistor is this. So this arrow mark is going from this here to here. PN, going to be PNN or NPN. NPN. This is going to be what, sir? It's going to be PN and then P. PNP. Now here when the collector is grounded, if I put input here, now what happens, sir? The base is given as an input in this case. Now what happens, sir? There is no possibility of electron generation. So because of that, emitter is at the output side. Of course, sir, when we completely do this configuration, we'll see in a different way. I'll show you in a different way. You need not worry. I'll clearly explain you when collector configuration, common collector configuration figure comes when we are discussing about input-output characteristics. Input-output characteristics or configuration and working of this collector configuration. So input-output configuration we will see in detail. Now again here, emitter base is the input and emitter is at output. Emitter is at the output, and this collector is again grounded. But generally in the circuit we will not use like this. So I'll show you in detail when it comes the configuration. So this is NPN transistor. This is going to be PNP transistor. NPN transistor and PNP transistor. Okay. Now we will see in detail about this common base configuration. In this configuration, the input signal is applied between emitter and base, while the output is taken from the collector base. Yes, as a base is common to input and output circuits, hence the name common base configuration. The figure shows the common base configuration transistor circuit. Now we will see. You can see here which type of transistor is this? Sir? Which type of transistor is this? Is it not PNP? PNP, because the current direction is from emitter to base. Is going to be PNP. So now when this is P-type material, so as I told you always, what thumb rule, sir? Thumb rule is emitter base junction. Emitter base junction should be forward biased. And collector base junction should be reverse bias. This is a thumb rule. You have to remember. Correct, Vasu, that is PNP transistor. Correct, Vasu, that is PNP transistor only. Now, as I told you, this junction PN, that's the emitter base junction, has to be forward bias. Means the positive end of the battery is connected to the emitter, and negative end of the battery must be connected to the N, that is base. Now, this is a forward bias. Now, what is this, sir? Now you can see here. Now, this is N-type material, must be connected to the positive end of the battery, and collector must be, that is P-type material, must be connected to the negative terminal of the battery. So what happens, sir? This is going to be reverse biased. This is going to be reverse biased. Reverse biased. Reverse biased. Okay. This is going to be forward biased. This is going to be reverse biased. This is going to be forward biased. This is going to be reverse biased. Forward biased and reverse biased. So I think something is missing here. I think it has gone here. It's going to be minus IC by IE. Okay. Now very important thing. When no signal is applied, you forget about this. When no signal is applied, then the ratio of collector current to the emitter current is called DC alpha or alpha DC of a transistor. Remember this. When no signal is applied, the ratio of the collector current to the emitter current, is alpha DC. Can somebody tell me what is this negative sign? It signifies that the IE flows into the transistor while IC flows out of the transistor. That's what, remember this here. So current I is flowing into the transistor, IC is going out of the transistor. So because of that, this minus sign, sir. You need not worry. Can somebody tell me what is the maximum value of alpha? Can you tell me what can be the maximum value of alpha? Vasu or Krishnaveni, can you think the value? What can be the value of alpha? Alpha is always, remember, it is the ratio of collector current to the emitter current. 0.99. Okay. Vasu, can you please guess some number? Maximum. Less than 1. Okay. Krishnaveni says less than 1. Vasu, are you there? Okay. Very simple, sir. You know, how did we get this value? Why did we get this value as 1? Very simple, sir. We know that IE is equal to IB plus IC always. Yes or no? Always yes or no? Let's say when IB becomes 0, IE is almost equal to IC. No, irrespective of the type of the transistor, Vasu, irrespective of the type of the transistor, alpha DC is negative because it is, see, even in the other case, even I will tell you, if this is PNP, what happens, sir? Current IC will go out of the transistor and IC will enter into the transistor. Right? Here, what's happening, sir? Here the current is, IE is going like this. IC is going, see, if this is the transistor, current IE is coming in. IB and IC are going out. IC and IB are going out. This is PNP. If it is NPN, what happens, sir? Current is going out. If this is the transistor, IC current is coming in, and then this IB current is also coming in. So two IB and IC currents are coming in, and IE is going to be going out. So obviously the alpha value will not change. No. Yeah. You are right, Krishnaveni. Just for the sake of when compared with, I'm talking about when compared with IC value. See, if this is 9, this is 5. So 5 is far less than 95, right? So, but just for the sake of convenience, I'm assuming that IB can be neglected just for the sake of convenience. If that is the case, IE becomes IC. So alpha ranges from 0 to 1. Alpha ranges from 0 to 1. Less than 1 only I have written. Less than 1 only I have written. Is the point clear? Okay. So whenever IC becomes IE, then it becomes 1. So generally, I can also write this also. Alpha becomes 0. When can alpha become 0? When IC is equal to 0. Or I is infinity. I is infinity. I cannot be infinity. IC cannot be actually 0. When IC is going to be 0, alpha DC is going to be 0. But generally, it will not happen. Right? So alpha of a transistor is a measure of quality of the transistor. So the alpha ranges from, as I told you, 0 to 1, 0 to 1. So why, sir? So if all what is the it that what is the what alpha represents? What alpha represents? Alpha represents the quality of a transistor. Alpha represents the quality of a transistor. Quality of a transistor. What does it mean? Higher is the value of alpha, better is the transistor. Higher is the value of alpha, better is the transistor. In that sense, collector current approaches emitter current. This is what I am trying to help you. This is what I am trying to help you. It means whenever this collector current is almost equal to emitter current, there is no loss in the base. And there is no loss in the base. What we generally expect, sir, we don't want to lose anything, right? We don't want to lose even 1% of the current. We don't want to lose 1% of the current. We want all the emitter current should be present at the collector current. We want the entire current of IE wants to be present at the collector. We want entire emitter current wants to be present at the collector current. So we always prefer. So now IC will always less than IE, but still we assume that someday collector current will become emitter current. We desire that collector current should become emitter current. So higher the value of the alpha, better is the transistor. Better is the transistor. So preferably alpha should be as close as possible to 1. As close as possible to 1. As close as possible to 1. Okay. As close as possible to 1. Okay. Now, by considering only magnitude of the currents, so IC is going to be alpha IE. Yes or no? From this only. See, this alpha is going to be, IC is going to be, just I am trying to multiply. So IC is going to be, I also said, let's consider only magnitudes. Only magnitudes. So IC is going to be alpha IE. IC is going to be alpha IE. So alpha IE. And then, what is IB? We already know that. IE is going to be summation of IB and IC. I is going to be IB plus IC, which we know we have a thumb rule that always the emitter current must be summation of base current and collector current. So if you want to write IB, so IB is going to be what, sir? Simply it's going to be IE minus IC. IE minus IC. So he's also just mentioning here IE minus IC. Therefore, IB is going to be IE minus alpha IE. Because just now we assumed that IC is going to be alpha IE. So what we can do here is we can write IB is equal to IE into 1 minus alpha. 1 minus alpha. What is alpha, sir? Alpha is IC by IE. So again, what will it say? IB into IE minus IE into IC by IE will get cancel. Again, you will get this formula. IB is going to be IE minus IC. So when the signal is applied, the ratio of change in collector current to the change in emitter current at constant collector base voltage is defined as current amplification factor. Current amplification is going to be change in IC by change in IE. Change in IC by change in IE. But for all practical purposes, alpha DC is equal to alpha AC is equal to alpha. And practical values, commercial values is going to be range from 0.9 to 0.99. So this is the preferable. Though I said alpha ranges from 0 to 1, but most preferably alpha should be lies between 0.9 to 0.99. 0.9 to 0.99. This is very important. 0.9 to 0.99. 0.9 to 0.99. Okay. Now here comes the total current, the total collector current now. The total collector current. So collector current is due to the majority charge carriers, that is alpha IE. Alpha IE, which you have seen is going to be IC, right? It's going to be IC. And then you have IC B naught, that is collector base reverse saturation current. Collector base reverse saturation current. Collector base reverse. So this formula is very important formula. With this formula is very important formula. So the total collector current IC is going to be alpha IE plus ICB naught. Alpha IE plus ICB naught. So what is ICB naught, sir? This is the minority charge carrier. As I told you, in any part of the transistor, the current is going to be summation of both majority charge carrier current and minority charge carrier current. Majority charge carrier current and minority charge carrier current. So IC is going to be the summation of two currents, that is alpha IE plus ICB naught, where ICB naught is the minority charge carrier current, or you can say it's a reverse saturation current of a common base, configuration. Okay. So the total collector current, always remember, is going to say this. Many formulas, many problems we can do based on this formula. IC is equal to alpha IE plus ICB naught. IC is equal to alpha IE plus ICB naught. This is very important. This is very important. Alpha IE plus ICB naught. Alpha IE plus ICB naught is very important. Remember this formula. So collector current is a combination of majority charge carrier current. This is majority charge carrier current, and this is minority charge carrier current. Majority charge carrier current and minority charge carrier current. Majority charge carrier current and minority charge carrier current. Now the collector current can also be expressed as, now what is saying, sir? This IE, sorry. The collector current can also be expressed as, you can see here, this is IE we can say, but what we know IE is going to be, why BJT is current controlled device. See, we will discuss in detail. We need some base to discuss that point. Whenever that point comes, we will discuss it in detail, Krishnaveni. Okay, just give some time. After finishing the base of the topic which we need required. So why it is called current control device? We will discuss then. Definitely we will discuss. I still remember you also asked me to discuss another topic also. That also we will discuss. Anyway, we will be shifting it to Unacademy app. There we can discuss in detail also. Okay. Now I'll substitute this IE with IB plus IC. Yeah, I still remember scattering mechanism. Yes, Krishnaveni. Oh, yeah. At least I can have a 30 minutes session on scattering mechanisms. You need not worry. On scattering mechanisms, I can create a half-an-hour session on scattering mechanisms. Right? Even Vasu, if you want to know any topic specifically, you can just post me We will also discuss, right? If anybody wants to have any special topic to be discussed, definitely we will discuss it in the app. We have a facility, right? We have a facility that we can plan for a half an hour session, 1 hour session, maximum of 1 hour session. So at the end of this class, we will discuss about that also, right? So just we'll finish off here. So now I'll place I is going to be IB plus IC. So if IC is going to be, now I'm writing here IC is equal to alpha into IB plus IC B naught, which we have. So if this alpha IC, so it means I'll write this step here. It will be alpha IB plus alpha IC plus IC B naught. So if this alpha IC goes here in this side, so what happens is going to be minus alpha IC. So IC into 1 minus alpha is equal to alpha IB plus IC B naught. IC B naught. So IC can also be expressed as alpha by 1 minus alpha into IB plus 1 by 1 minus alpha. See, this previous IC is in terms of emitter current, collector current in terms of emitter current, collector current in terms of emitter current. And here it is collector current in terms of base current, collector current in terms of base current. So what is alpha? What is alpha? Current amplification factor. We can call this the amplification factor. Why it's called? See, I think I forgot to discuss this point here. So we call this as the current amplification factor. Current amplification factor. Why it is called current amplification factor, sir? This is the ratio of two currents. This is the ratio of collector current and emitter current. That is, what is this collector, sir? Is it not output current? So this is going to be output current by input current. Input current. So the always output by input generally we measure is as gain. Gain. The gain also you can call another is amplification. Amplification is increasing the strength of a weak signal. Increasing strength of a signal is amplification. By definition, what is amplification is increasing strength of a signal. Increasing strength of a signal. So this is that is the way it's called amplification. So output current by input current. Output by input. Output by input. The reason why it's called amplification. This is called amplification. So alpha is going to be IC by IE. Alpha is going to be IC by IE. So IC is going to be alpha IE plus IC B naught. So this is the formula collector current in terms of emitter current. Collector current in terms of emitter current in common base configuration. Remember this common base. That is why IC B naught has written. IC B naught has written. So this is in terms of base current. This is in terms of base current. In terms of base current, this IC is going to be alpha by 1 minus alpha into IB naught plus 1 by 1 minus alpha into ICB naught. ICB naught. Where ICB naught is a minority charge carrier current in collector. Minority charge carrier current in collector. So remember those two formulas. Sir, it is okay even if you don't remember. You can convert all of them very easily. Convert all of them. Sir, by practice, sir, what you will do is as many number of problems as possible. If you discuss, then all these formulas you will remember all these formulas. You will be definitely remembered all these formulas. Sir, I would suggest all of you those who are listening second year, especially those who are second year, have a specialized notes after listening to my class. Right? You should have some special notes you can prepare, because as you are in second year, so when you go to third year and final year, you'll lose the touch with the subjects. You lose touch with the subjects. So because of that, now what I request is, after listening to my class or while listening to the class also, anyway, this notes is available with you. This soft copy of my notes is available with you. But what you need to do is still you need to write some points, and whenever you study those 2 points, you will get it. So probably in 2023 you may attempt gate examination. So for that time, again listening to all my classes may not be possible for you. But what the best thing is, when you are listening to my class, have a separate notes, a small notes, or after listening to my class, after seeing my notes from the Telegram, prepare a separate small notes. Prepare small notes of your own words or in your own things. See, the examination answer which I write may be different, what you may write different. So what I would suggest is have separate notes, right? Prepare your own separate notes so that it will be useful for you. So that it will be useful for you. Okay. Okay, let's move on. So this is what IC is going to be alpha by 1 minus alpha into IB plus 1 by 1 minus alpha into ICB naught. Now we will see common emitter configuration. Common emitter configuration. So in this configuration, the input signal is applied between base and emitter, and output is taken from collector and emitter. Collector and emitter. Collector and emitter. As emitter is common to input and output circuits, hence the name common emitter. This is what we discussed from last 1 hour. Okay. Now you can see, first thing is always remember, first you need to identify which type of transistor is this. Which type of transistor is this. So as current is flowing from here to here, this is P type, this is N type, this is P type. So it is PNP transistor. PNP transistor. Sir, if you want to draw for an NPN transistor, no problem, still you can draw that NPN transistor. First job of you is to draw a transistor. First job is to draw and so as you are saying this is emitter, you want to do it emitter. So as this is emitter, emitter is common, then so what we know, sir. So let's say this is a resistor. Obviously, this is a base. So I should use this word, something called base resistor. And this is emitter, and this is collector. I should use a word. This is collector resistor. Now, what I'm saying, sir, I'm saying this is going to be NPN transistor. So this is NPN. So definitely arrow mark should be from base to emitter, base to emitter, base to emitter. Now, always what we discussed is, this emitter base junction has to be forward biased. So this emitter base junction has to be forward biased, means the positive in the battery must be connected to the positive terminal. See, the P terminal of the the P region of the semiconductor must be connected to the, so P minus, so positive, negative, and we use some word called VBB. VBB. Now you can see here this N and N. So this collector base junction has to be reverse bias. Collector base junction has to be reverse bias, means this N must be connected to positive. And we use the word VCC. We should use the word VCC. So don't get confused. Don't get confused. So plus and plus. You can see here this is plus and then minus. Don't see about E. So this emitter base junction and collector base junction. So collector is important here. Emitter is not important. Emitter job has done. So while we are discussing about input side, emitter has considered. While we are discussing about output side, we are considering collector. This is very important. So here, now you can see here, this is N region. So negative terminal is connected, and this is P. Positive terminal is connected. Why I am focusing on this emitter, common emitter is, common emitter has more applications. Very important configuration. Very important configuration. That is the reason why I am stressing a lot. That is the reason why I am stressing a lot on this. This is why I am stressing a lot on this. So you can see the current directions. One current is coming in, the remaining two currents are going out. One current is coming in, the remaining two currents are going out. Okay. So this positive is connected to the P. So from this, what I can say, this is forward biased. This is forward biased. This junction is reverse. This junction actually, this junction is reverse bias. I can say this junction is reverse bias. This junction, collector by junction is reverse bias. Collector by junction is reverse biased. Okay. So now, earlier the current amplification factor for a common base was alpha. Now, a current amplification factor for common emitter, we assume that is going to be beta. We assume that it's going to be beta. So what is beta, sir? Beta is again output current by input current. Output current by input current. And you can see here, there is no minus sign. There is no minus sign. Why, sir? Why there is no minus sign? Why there is no minus sign? Because both currents are leaving. Both currents are leaving. So if you look at here, so this is what you are looking. So IB is going out, IC is also going out, and only IE is coming in. Only IE is coming in. So because of that, so now that there is no minus sign. There is no minus sign. There is no minus sign. Okay. There is no minus sign. Are you guys listening? Are you not getting any doubts? Is the point very clear so far? Is all the points clear so far? Okay. Okay. Krishnaveni, okay, very good. Vasu, yes, Vasu. I think there is one or two people still they are in silent mode. I don't know why they are in silent mode. They are not replying. They might be having shy. They might be having some shy. Yesterday Sam was there. I think today Sam is not there. So Sam is there. Okay. Now beta is the current amplification factor of common emitter configuration. Remember, current amplification factor of common emitter configuration. When current amplification factor of common emitter configuration is beta, it is again output by input. What is output current? What is the output current? Is it not collector current? So this is incoming collector. This base current is also incoming, and emitter current is outgoing. So output current is IC, and here input current is IB. Obviously, amplification factor is going to be IC by IB. Can somebody tell me what could be the value of this beta? What guess, sir, beta? Guess beta. So we have discussed that IE is equal to IB plus IC. What we discussed, sir, this phi is going to be 95. This is going to be 95. Example I'm telling you, this is worst case. Of course, sometimes it's going to be 1 also. It's going to be 1 also. 0.1 also. 0.1 also. Very, very low value. Right? Right? So beta value will be very high. What is beta? Current amplification factor of common emitter configuration. Current amplification factor of common emitter configuration. Very simple, sir. IC is always far greater than IB. So even if you take this, it's going to be 99 by 1. So it's going to be 99. It's going to be 99. Or worst case, let's say what you have taken 95 by 5. So 5 ones are then 19. Almost minimum 20%. Correct, Krishnaveni. This IB is very low, very low. So IC is very high. So because of that, beta value will be very high. Beta value will be very high. So this is all about this alpha beta DC is now when you are now applying, no signal is applied. But see, sir, no signal is applied means don't think that I am not applying any DC signal, sir. Sir, don't think that no signal is applied means this VBB VCC are not there. If you are thinking like that, you have mistaken. These voltages are called biasing. This VBB and VCC are called biasing voltages. Biasing voltages. Don't think, sir. If you think that this word no signal doesn't mean no signal doesn't mean no biasing voltages. No biasing voltages. It means no AC signal. Remember this point. No AC signal. It means if AC signal applied, how it will be? I'll show. I'll draw one thing here. This is the AC signal. This is the DC signal which you are applying. These are the biasing signals. This is emitter. This is collector current. You'll have a base resistor RB also. You not worry. And I will use this word VCC. Sir, this is a transistor Q. General representative is nothing but it's going to be NPN transistor. Sir, no signal is applied means there is no AC signal. Only biasings are there. These biasing voltages are there. I mean to say, these biasings are there. Don't get confused with something called no signal. No signal means no AC signal. No AC signal. No AC signal. There's a difference. Don't always think that no signal means it means always no AC signal. Definitely DC signal will be there because it has those DC signals are biasing signals. Those DC signals are biasing signals. They need to be there. They must be there. They must be there. Generally, students think that no signal is applied means they think that DC signal is also signal here. DC voltage also signal. No, DC voltages are called biasing voltages. They need to be there definitely. They need to be there definitely. They need to be there definitely. See, whatever signal you apply is on top of it. On top of the DC signal, you are applying AC signal. And you will see how much this signal is amplified. How much this signal is amplified. How much this signal is amplified. That is the reason why we use this beta AC as a delta IC by delta IB. Delta is IC by delta IB. That is when signal is applied, the ratio of change in collector to the change in base current is defined as base current amplification factor. Base current amplification factor beta AC is going to be delta IC by delta IB. Delta IB. So don't never confuse with the word no signal. No signal. Correct. The operating point discussion we will do it. Okay. It will be delta IC by delta IB. It is change in output. Change in output current by change in input current. So how much output current is changed by changing the input current? By changing input current. Okay, this is very important. This is very important. So again, what is saying, sir? From equation 1, so IC is going to be beta times of IB, right? So almost all transistors, in all transistors, the base current is less than 5% of the emitter current. So due to this fact, beta ranges from this. Just now we discussed. Just now we discussed that beta can be minimum of 20. Minimum of 20. It can be a maximum of 300. Maximum of 300. Right? Sir, you can measure you can measure the beta value in your voltmeter. In your volt, you will use digital voltmeters in your laboratory, right? You will use digital voltmeters. Why you are using intrinsic semiconductors? So Vasu, we have came very much forward. If the base is intrinsic, then why we use something called PNP transistor or NPN transistor? When this is not P type, this is not N type. No use of this. No use of this if you use intrinsic semiconductor. All the three parts of emitter, base, collector must be added impurities. Added impurities must be added impurities. There is no point having this base as intrinsic semiconductor. Intrinsic semiconductor. There is no point in having intrinsic semiconductor. If it is intrinsic semiconductor, there is no current flow at all, because intrinsic semiconductor acts as an insulator at 0 degrees Kelvin. So there is no point. But we said this is going to be a lightly doped. Yes or no? It's going to be lightly doped. Definitely, it needs to be lightly doped. And how do you represent this? How do you represent this? NPINN or NPNIN? No, this is not correct. This is not correct at all. This is not correct at all. I think your question has answered. Okay, was okay. So IB is going to be beta times of IB. So the beta always ranges from 20 to 500. 20 to 500. Hence, this configuration is frequently used when appreciable current gain as well as voltage gain is required. Remember, common emitter configuration will be used for both voltage configuration and voltage amplification, and then current amplification. We will come back to this point again. Current amplification. Both current amplification and voltage amplification can be done with the common emitter configuration. Because of this is the most used configuration. Common emitter configuration is the most used configuration. Most used configuration. Okay. Yeah. Now we'll calculate the collector current. We'll write collector current. So IC is going to be B times of IB plus IC naught. You see here this word IC naught. What is IC naught? This is the collector current in common emitter configuration. This is the minority charge. This is the majority charge carrier current. This is the majority charge carrier current. This is going to be minority charge carrier current. Minority charge carrier current in. So IC is going to be beta IB plus IC naught, where IC naught called leakage current. Leakage current. Leakage current. Now, but we have, see, from the previous discussion, what we derived, sir, we have derived IC, collector current, is going to be alpha by 1 minus alpha into IB plus 1 by 1 minus alpha into IC B naught. Now if you compare these two, IB is there, IC naught is nothing but, now this This beta is going to be alpha by 1 minus alpha. Beta is going to be alpha by 1 minus alpha, and IC naught is going to be 1 by 1 minus alpha into ICB naught. ICB naught. This is also important. So the relationship between beta and alpha, that is current amplification factor of common emitter configuration and current amplification factor of common base configuration, is going to be beta is going to be alpha by 1 minus alpha. Just see, Pritam, you are asking why common base or common collector can be used for both current and voltage. See, just simple. Because I did not finish common collector. I did not finish common collector, but see, I talk about this common base. In case of common base, in case of common base, so in case of common base, what is alpha? Current amplification factor is going to be IC by IE. IC by IE. So what we discussed here, what is the value of this? You'll get the alpha is maximum 1. So alpha maximum 1 means amplification is less than 1. Current amplification is less than 1. So what is the use of using this for current amplification? What the use of using this common base for current amplification? Because current output current is less than input current. Did we call it a, can we call this as amplification? No, never ever will call this as a amplification. Never ever will call this as amplification. So common base configuration should not be used for collector current amplification. Current amplification, because collector current is less than, output current is less than input current. That is why we don't use this for common base configuration, used for collector configuration. We'll talk about the voltage configuration later. Input voltage or output voltage we'll discuss. That we will discuss after seeing input output characteristics. Input output characteristics. Okay. So here comes beta is going to be alpha by 1 minus alpha, and IC is not going to be 1 by 1 minus alpha into ICB naught. ICB naught. So after comparing these two, beta is going to be alpha by 1 minus alpha, and IC naught is going to be 1 by 1 minus alpha into ICB naught. Now how will you find out the relationship between alpha and beta? Alpha and beta. Alpha and beta. Either you can write the beta is going to be. So now we know that alpha is going to be IC by IE, and beta is going to be IC IB. So I is going to be IB plus IB, IB plus IC. See, this all you know. IB is going to be IE minus IC. IE minus IC. So now beta is going to be what, sir? IC by, that is IB value. How you write IB? I'll replace this IB. IB is going to be IC by IB. IB means IE minus IC. I have written IC by IE minus IC. IC by IE minus IC. So it's going to be alpha by 1. So this we already derived after comparing these two. After comparing these two, what we got, sir? Is it not all beta is into alpha by 1 minus alpha? Alpha by 1 minus alpha. Same thing we got it, sir. Same thing we got it here. Alpha by, so I can say beta is going to be alpha by 1 minus alpha, or 1 minus alpha into beta is going to be alpha. If you still simplify it, what you will get, sir? Beta is equal to alpha plus alpha beta. Beta is going to be alpha plus alpha beta. So I will find out alpha. So simply what you need to do is, sir, so if you do everything, what you'll get is alpha is going to be beta by 1 plus beta you'll get. So you just cross multiply it, and you'll get what you want. So simply what it will say, sir, beta minus alpha beta is going to be alpha. So if you take it other side, it's going to be beta into alpha plus alpha beta. So if you take alpha common, what you'll get, sir, 1 plus beta. So from this, beta is going to be alpha by 1 plus beta. Alpha is going to be beta by 1 plus beta. Either beta in terms of alpha if you want. If you want beta in terms of alpha, beta is going to be alpha by 1 plus 1 minus alpha. If you want alpha in terms of beta, it's going to be alpha is equal to beta by 1 plus beta. Beta by 1 plus beta. If you want still some relationship directly, you can write minus 1 minus alpha is going to be 1 plus 1 by beta. It is a bit complicated to remember. Bit complicated to remember. So either you remember this formula, sir, alpha, beta. Beta in terms of alpha is going to be, beta is going to be alpha by 1 minus alpha. Or if you want alpha is going to be in terms of beta, beta is going to be 1 plus beta. Alpha is going to be beta by 1 plus beta. Okay. So if somebody wants you to remember like this, you can remember this also. 1 minus alpha is going to be 1 by 1 plus beta. 1 minus alpha is going to be 1 by 1 plus beta. Okay. So anything you can remember. This is the relationship between alpha and beta. This is the relationship between alpha and beta. Whichever you want to remember, you can remember. Remember this or remember this. So from this you can rewrite whatever you want. Okay. Now, here comes the other story, something called common collector configuration. Common collector configuration. In this configuration, the input signal is applied between base and collector, then an output is taken from emitter. And as the collector is common to the input and output, this is called common collector. And for PNP configuration, you can see here. First thing what you need to do, sir, whether collector is common or not. So this is grounded, no problem. No problem. So this is emitter. So current is flowing from emitter to base. It means it is P. This is N. This is P. P N P. So you can see here emitter has to be forward biased. Emitter base junction has to be forward biased. Emitter base junction has to be forward biased means this emitter must be connected to the positive terminal and base has to be connected to the negative terminal. You can see here this is connected to the negative terminal and this emitter is connected to the positive terminal. Okay, base is connected to the negative terminal. This N is connected to the negative terminal and the P is connected to the positive terminal. So this is called forward biased. Forward bias. This is most important. Many students will get confused in common collector. Many students will get common collector. Now just remember base if is N, it has to be minus. If it is E, it has to be P, means it has to be plus. Sir, if it is reversed, if it is NPN, if it is NPN, what will get, sir? You will get plus VBB here and minus VCC here. Plus VBB here and minus VCC here. Okay. Now the when there is no signal means again the current amplification factor is called alpha gamma. So gamma is again output current by input current. Output current is going to be IE and input current is going to be IB. Input current is going to be IB. In CC mode, base acts as no change in the any emitter. No. Still emitter is emitter only. Still emitter is emitter only. Emitter is emitter only. No confusion, Vasu. Emitter is emitter only. Base is base only. Base is base only. Base is base only. You need not worry. So whenever you apply some AC signal, you'll understand that. Whenever you apply AC signal, understand that. Common collector mode, base acts as an input. That's it. Not as an emitter. Emitter is emitter only. It just acts as an input. That's it. Emitter acts as an output. No, base acts as an emitter, emitter acts as a base. No. Don't get confused. Base is base, emitter is emitter. But the only thing is, base acts as an input and emitter acts as an output. Emitter acts as an output. Okay. So this is going to be gamma. Gamma is going to be output current by input current. Can you guess what is the value of this gamma? Obviously, IE must be very high. Pritam. So this is input only. When common collector is common, base has to be input and emitter has to be output. In common collector, base has to be input and emitter has to be output. In common emitter, base has to be input and collector has to be output. Base has to be input and collector has to be output. In common base, emitter is input, collector is output. Emitter is input, collector is output. Vasu, why it is less than 1? Why it is less than 1? You are getting confused, Vasu. IE is going to be what? IE is going to be IB plus IC, and IB is very, very less now. So IE will be very high if it is 1000. If it is 1000, IE is 1000 means this is only 10. Not even 10. Let's say it's only 1, and all 999 is going to be here. So if you divide IE by IB, what will get, sir? 1 means almost will get 1000 only. This should be also greater than 1, always far greater than 1, as sir only alpha should be less than 1. Both gamma and beta will be far greater than 1. Remember this. Only alpha and beta will be far greater than 1, or far greater than 1. Right? The configuration provides same current gain as common emitter configuration as. So now also what he's saying, sir? So he's saying beta and gamma almost same is saying. Beta and gamma almost saying this one. Anyway, we will see this in detail. But the voltage gain is always less than 1. For this, the voltage gain, current gain is very high. So common collector current gain is very high. Current gain is very high. Yes or no? I is far greater than IB. Obviously, this current gain is very high. But voltage gain is less than 1. That we will discuss. Voltage gain is less than 1. That we will discuss. Okay. Now what? Now we are talking about emitter current. That is output current. I is going to be IB plus IC. Also, we have seen IC is going to be alpha into IE plus IC B naught. So it's just substituting that value. So IE is going to be IB by 1 minus alpha plus 1 IC B naught by 1 minus alpha. IC B naught by 1 minus alpha. Or you can write IE is going to be 1 plus beta into IB and 1 plus beta into ICB naught, because we know that 1 by 1 minus alpha is going to be 1 plus beta. Just I am replacing 1 by 1 minus alpha is into 1 plus beta. This is what I am trying to do. Just I am trying to do this. So now how to find out relationship between this gamma and alpha. Gamma and alpha. We know that gamma is going to be IE by IB plus, and alpha is nothing but what is gamma, sir? This is current amplification factor of common collector. What is alpha? This is common base current amplification factor. So now we will replace this IB by IE by IC. So what we'll get is, so gamma is going to be 1 by 1 minus alpha. Sir, if you want to find out the relationship between alpha, beta, gamma, if you want alpha, beta, gamma, so we know that 1 by 1 minus alpha is equal to 1 plus beta. So this is the most important formula. Very important. That is, gamma is going to be 1 by 1 minus alpha, which is equal to 1 plus beta, which is equal to 1 plus beta. This is the most important relationship. This is the most important relationship. Most important relationship is gamma is equal to 1 by 1 minus alpha is equal to 1 plus beta. 1 by 1 minus alpha is equal to 1 plus beta. 1 by 1 minus alpha is equal to 1 plus beta. This is the very important thing to be remembered. So we'll stop it here. We'll discuss the remaining thing in the next class. I think we have a common configuration input output characteristics. So from next class we'll discuss about these characteristics. Next class we'll discuss about these characteristics. All this we'll discuss effect base width modulation also. This is very important topic to be remembered. We'll discuss that also. Reach through, punch through, everything is there that we'll discuss. Output characteristics also we will discuss. There is beauty to be discussed. I love to discuss all these things. I love to discuss all these things. Okay. Yeah. All the transfer parameters also we'll discuss in next class. Yes, we'll discuss all these things next class, sir. Right? So as I told you, from tomorrow, from day after tomorrow, Unacademy GATE Telugu has become Unacademy GATE English. Unacademy GATE English. This is you can ask every student of South India to subscribe for this Unacademy GATE English. Unacademy GATE English. And I have another big announcement here. A big announcement here from 4th Jan, from January 4th, from January 4th, I'm going to have a crash course of analog electronics, crash course of analog electronics, crash course of analog electronics to target, not, we are not still, we are still on to target GATE 2021. Don't think that GATE 2021 is already finished. No, still we have time. Still we have 40 days of time, 30 plus dates of time. Still, people who are serious about GATE 2021 can listen to my class and crack GATE by understanding this analog electronic crash course. Analog electronics crash course. Don't miss this. Don't miss this. Okay, I'm going to start this new course called Analog Electronics crash course on start from 4th January. So this class is going to be from 4 p.m. to 5 p.m. 4 p.m. to 5 p.m. 4 p.m. to 5 p.m. by myself, Shravan Kumar sir. Myself, Shravan Kumar sir. Okay. So this will be on YouTube channel. This will be on YouTube channel. This will be on YouTube channel. Okay. Next. This is announcement which we already made. So these notes will be there. So now my question is so from as I told you from Monday, now you people should tell me Vasu, Krishnaveni, whoever are there, Preetham, whoever are there. So these notes will be available here. So from 4 p.m. to 5 p.m. 5 p.m. on YouTube. So I'll be available taking analog electronics. Analog. This is 1 hour session. This is 1 hour session. So I'll take 2 hours of EDC. 2 hours of EDC on app, on Unacademy app. Unacademy app. The problem here is I can't take 2 hours continuously in app. So I have to take 1 plus 1 hour. 1 plus 1 hour. 1 plus 1 hour. Right? So what did you propose? Shall I take from, anyway this 4 to 5 I am occupied. So shall I take from 6 to 7 and 8 to 9? 1 hour plus 1 hour. Is that okay for you? This is on Unacademy app. Unacademy app. Because if I take before 4 p.m., you will be going to colleges. You'll be going to colleges. So what I'll do is 6 to 7, 8 to 9, or 6 to 7 or 7:30 to 8. Something by 9 I have to finish. By 9 I'll finish. Is Vasu is comfortable? Is Krishnaveni you are comfortable? From Monday only I'm going to start this. Hope you are comfortable from 6 to 7 and 8 to 9. 1 hour plus 1 hour. Or even if you want me to take from 6 to 7 and 6:30 to 7, 8:30, still I'm comfortable. 7:30 to 8:30, I'm still comfortable for that also. With 1 hour gap, I'll take this 2 hours. EDC 2 hours. As somebody was discussing yesterday, I think Balaji asked me to do this. So 6 to 7 and 7 to 9, I'll take Unacademy app classes, 2 hours. 2 hours continuous, 2 hours with a gap. But I don't have the opportunity to take 2 hours continuously in Unacademy app. So because of that, I'm taking 1 plus 1 hour. 1 plus 1 hour. Right? 1 plus 1 hour. Right? So my WhatsApp number is WhatsApp number. My WhatsApp number. Does anybody has? Okay, Krishnaveni. Depending on my availability, I'll tell 1 hour is that definitely from 6 to 7. 1 hour is definitely from 6 to 7. Whether second hour is 7:30 to 8:30 or from 8 to 9, I'll decide. I'll decide. Okay, depending on my availability, I'll change this second hour. But 6 to 7, hope 6 to 7 you are comfortable. Hope you are all comfortable 6 to 7. Does anybody has my number? Does anybody has my WhatsApp number? So that I will be sharing the links. So that I will be sharing the links of the classes. Or otherwise, if you register, if you follow me on Unacademy app, you'll get all updates. Preetham, do you have? If you have my number, please share with others. My WhatsApp number is, you just ping me on my WhatsApp. That is 9290837600 is my WhatsApp number. Is my WhatsApp number. You can just ping me. You just ping me. You just ping me so that I'll be sharing everyday classes. Everyday classes. I'll ping you separately. I'll ping you separately my class links. Or if you or what you can also do is you can simply follow me on Unacademy app. You can follow me on Unacademy app. You'll get the notifications. You'll get all the notification. Either you can do anything. Either you can drop me a message in my WhatsApp number, and or if you share me your WhatsApp number, I'll keep sharing my classes details. Or you can follow me on Unacademy app. That's also much great. You will get notifications from that. You get notifications from that. Okay. So these are all our YouTube channels right now which we have. So Creatix Gate, Unacademy Gate for mechanical engineers and civil, everybody civil engineers we have. Gate, Unacademy Gate to separate. The computer science we have, engineering Pathshala we have, Unacademy Gate Telugu. This will be converted to English. Unacademy English we are going to have, and electrical engineering, electrical junction. Okay. Next. So thank you, sir. Sir, don't forget to like, share, subscribe, and bell icon. Hit the bell icon. Hit the bell icon. Don't forget to like it. Like it. We'll catch from Monday. We'll catch up from Monday. We'll catch up from Monday on Unacademy app. Of course, on YouTube also. On YouTube also. So this YouTube session from 4 to 5 is also very important. If you guys can attend come online, that is also great. It's also great. But if you are unable to come online, that's okay. But don't miss my app classes. They're also very important. So I'll continue EDC there. Okay. Right. Thank you. Bye. Good night. We'll catch up on Monday.